I want you to do today, you can call a friend if you want to and kind of collaborate on this and work on this together, that's fine. What I want you to do is I want you to determine if the distribution of these test scores are approximately normal. And you will want to justify your answer using several different approaches. So things I want you to think about. I want you to think about graphs. I want you to think about the mean and the median. I want you to think maybe about the empirical rule. Okay, so you can go to, if you want, if you think this will help you, you can go to Stacklet.com to input the data, and you're going to want to go to one quantitative variable, single group. If you elect to do that, especially if you don't have a calculator, that might be something you'll want to do because it will calculate all the numbers for you. Or you can put these into your calculator and find the same information. So what I want you to do is collaborate with somebody. If you can find somebody, if you can't, do the best you can. And I want you to come up with a justification and then come back to the video and we'll talk about it. All right, well, let's take a look, guys. So this is I did a dot plot because I wanted to use the empirical rule, so I felt like I wanted to have some data here so I could see, I wanted to be able to see the numbers and how it kind of hashes out for me. So let's look. Well, the first thing I'm just going to go ahead and compare the mean and the median. So the mean was 79.7 and the median was 80. Well, those are almost equal to each other, so this makes me think normal. Okay? All right? But when I'm looking at the shape, I don't feel like it's normal. So I took the empirical rule. So remember, the empirical rule says the percentages that show up in each section. So I'm going to take my mean, which is like right about there, which was 79.7, and I'm going to mark out my standard deviation lines, and I'm going to see what percentages of numbers actually turn up. So if I add one standard deviation, I ended up with 88.366. So there's 85, 86, 87, 88. 88.366. Okay, that's the mean plus one standard deviation. When I added another standard deviation, I got to 97.02. or 0.032. That is the mean plus two standard deviations. And for my third standard deviation, I got 105. So 100, 1, 2, 3. Okay, so it's sort of like there, 105.698. That's the mean plus 3 standard deviations. So I went ahead and did the same thing on the other side. So I got 71.034 for the mean minus 1 standard deviation. I got 62.368 for the mean minus 2 standard deviations. And then I got 53, I had a couple more tick marks there, 0.702 for the mean minus 3 standard deviations. So it's kind of like when we're doing the normal curve, okay? So I wanted to see the total number of numbers. I know that my n is 80. So whatever number of numbers I have in each section, I'm going to divide it by 80 to get the percentage of the total in there. So in 55 to 60 area here, this last standard deviation, I got 1, 2, 3, 4 numbers. And if I divide 4 by 80, I got 5% out here. Okay, in this section, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when I divided, that was 11%. In this next section, when I counted, I got 20 numbers, which is 25%. And then in this section, I got 35 numbers, which is 44%. Here, I ended up with 12 numbers, which is 15%. And then in this last section, there was nobody, so that's a 0%. So this doesn't match our empirical rule. And remember, a lot of what we're dealing with is not actually truly normal. That's why we like to say the words approximately normal, and it even says right there, approximately normal. So it doesn't have to equal it exactly, but I don't know, this didn't convince me. Like, I felt okay saying this was normal. I don't feel super convinced here because this does not match the empirical rule. So I'm feeling questionable. And what I want to do is I want to show you something that you can do that will really be the way you're going to assess normality the majority of time, because on a test you don't have time to do this. So I'm going to show you how to do this in your calculator. All right? If you don't have a graphing calculator yet, you really want one for this class. So remember, you have to hit the stat button right here, and we're going to edit the list, and you're going to put all 80 values into the list. Remember to hit enter after each one. So I have all 80 values in here. I'm going to press stat again, and then go over to calculate. And we only have one column of information we're talking about, so we do the one variable stats, which should be the top one already highlighted. Hit enter. Everything's in list 1. Leave the frequency list blank. All right, here we have our information. X bar, that's our standard deviation, is 79.7. Our mean. Our standard deviation, it was a sample, so SX, I used the sample standard deviation of 8.66. All right, and then down here, I had that 5-number summary. If I wanted to make a box and whisker plot, I could. So what I'm going to tell you about is something called a normal probability plot. Normal probability plot. Okay. So, in many of your classes, you probably did y equals and put the equation in. I want to go into stat plot right above there. So see how it's in blue? That means hit the blue button first. So I'm going to say second y equals, and it takes me into stat plot. I'm going to go into the very first one. Now yours probably says off, so you just highlight the on and press enter. Okay? I'm going to arrow down, and this is the different kinds of graphs that you can make. There's a histogram. There's 2 different kinds of box and whisker plots. There's some line graphs, but we want to go all the way over to this one that looks like a dotted line going up. That is your normal probability plot. Select it. Make sure it's collecting the data from where we put the data in list 1, and the rest of it should be okay. And you're going to tell it to graph. So look, I've got something else in there. That's because I happen to have something in y equals, so I'm just going to delete that out. Hit the graph button, and now it's gone. If you do not see this, and it's very likely you won't, you want to hit the zoom button, zoom, and then choose number 9. And you can arrow down, or you can just press number 9, and it will zoom in so you see your graph. So what we want to do is we're going to copy this. I'm going to kind of show this like that. And I'm not going to be super excited about this. I mean, I'm not going to be very, very picky. What I'm going to do is I'm going to look at these points, and I'm going to kind of approximate them on here. So these thicker ones is where the same number kind of appeared more than one time. All right. So I just did a little rough sketch, and that's okay. That's perfect. So what I want to look at here is, in my normal probability plot, how straight is this data? This is fairly straight. So this means this data is approximately normal. So what I like about the normal probability plot is usually you've already put all of your data into your calculator, so you could get the numbers out anyhow. So this is just one more step to graph it, because what if I gave you 80 data points and you're trying to figure it out and this is what you got? I didn't feel comfortable with anything right here. So when I looked at my normal probability plot, it looks fairly straight. That means approximately normal. Okay? So let's summarize some of this stuff. All right, some big ideas. So to check normality, you want to make a graph. You want to compare your mean and median. You want to check the empirical rule. And you can check your normal probability plot. Okay. So your normal probability plot, this is really what you're going to be seeing on it. This is really your expected z-score over here. Zero to some value out here, and that's your x-axis. Okay, so we're just going to do kind of a sketch on here. Doesn't have to be perfect. So if it's fairly linear, it's normal. Equals normal, and probably instead of just normal, add the word approximately in front of it. You should use that to hedge your bets pretty much all the time, approximately normal. Okay, so let me show you what not approximately normal looks like so you kind of have an idea. So if we a skewed right normal probability, we'll have our graph. But a skewed right, like it bows down and then comes back up. Okay? This is skewed right. A skewed left, normal probability plot, does just the opposite. Okay? It's instead of bowing down, it's going to bow up like this. Okay? So curving is bad. It's not normal then. If you have a fairly straight normal probability plot, you're approximately normal. Okay? So what I want you to do is I want you to go ahead and pause the video and answer this question and then come back to see how you did. All right, so let's take a look. I have here the distribution of CO2 emissions is not approximately normal. The normal probability plot is not linear. Okay? That fully explains it. I didn't use a ton of words. I want to caution you, though. Be very careful here. I want you to be precise with your language. Okay? I do not want to see it is approximately normal. What is? I don't know. This, I do not want to see this. No, 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 no. Okay? Do not say it is. What is? The distribution of the CO2 emissions is not. Okay? Because it is not linear. Here's another example. That could have been our second, because what is not linear? You need to be precise and tell me what you're referring to. So these are big, fat no-nos. Do not start a sentence or refer to what you're talking about as it. Name it specifically. Okay? All right, looking forward to seeing everybody in class.